I think microservices are technical debt. I think everyone, to a certain extent, makes a distributed monolith. I'm one of these people who thinks that Go is a good programming language.
A week ago, I made a video talking about a blog post that Doordash posted where they discussed transitioning from a monolith over to a microservices architecture. So they had a Python monolith and they split it into microservices. It's better for a team to own a microservice because it can be deployed independently. And one of the original authors of that post, who's an engineering leader over at Doordash, his name's Matt. He actually saw that video. And so I got to sit down and actually discuss microservices, and he had actually quite a lot of interesting hot takes. And I definitely learned a lot just kind of hearing his experience over like the last couple decades with microservices. And I think you'll learn a lot from it too. It's just a Google Meets, like the footage itself is just me and him in a Google Meets, but I don't think you guys care about that. I know you guys probably care more about the substantive stuff in the video. So I think it's definitely worth your time.
I'm just one person. I don't speak for the company, but I can tell you how the company is thinking about these things. And it has changed since we wrote that blog post. I think there are some topics about microservices that are really interesting, that if you're curious about this sort of thing, like this is like, there's some tricky bits in here that I think people should talk more about. So what I think the first thing you should start with is really why would you make a microservice? But like, so if I were to ask you, like just in your own, regardless of what I'm doing at Doordash, why do you think someone should ever make a microservice?
Yeah, I think that's a good question. So it kind of takes me back to just like what exactly is scaling. And so when I was kind of reading the Doordash post, I initially thought, well, if they got this far with like a pretty large monolith, which of course, like I've never gotten to the point where I'm scaling a monolith to a very high degree, nor have I gotten to like that cusp where it's like, okay, well, this is the line where if you jump over that, that's the point where microservices are worth it. And if you go to the other end of that line, maybe you just want to stay away from them. And I guess maybe this is what you're getting at, where people think that line is maybe changing over time. And I think for many companies, I'm sure it is worth it. My short experience at Google made me realize that, well, if they have all this tooling already set up and they have like a large team of dedicated SREs that are handling all of this, it's probably worth it at that point to, stick with microservices. There's really no need to simplify like the architecture, because we really didn't have to worry about those kinds of issues, like those latency things. Right, that was abstracted away from us. And so from that perspective, I think it's worth it.
Google has very mature tooling. They've been at this for longer than basically anybody. And so you would sort of expect that their stuff works really well. Like that's, I guess, you shouldn't be too surprising. But also, you probably can't take what happens at Google and infer too much about how to like make that be advice for anyone else. But so I really want to stick to that, to the why though, because I think it's super interesting. So like, why would you take your monolithic application, doesn't really matter what language it's written in, where there's a single deployable artifact, like one big binary, one big ball of Python code, like one, whatever, language you write it in, but it's like one thing. Inside of it, the modules talk to each other by making function calls. And when you want to change it, you just deploy the whole thing, right? The monolith, right? So like, what would make you ever want to do a microservice? Or I hate the word microservice, honestly. Just what would ever want you to introduce the idea of making gRPCs or RPCs network calls instead of function calls? And I think that the answer usually works out like this. You're cruising along in your monolith and everything's fine. And then your company, starts to get bigger, your development team starts to get bigger, maybe your user base gets bigger, but like the scaling of the traffic is not, I don't think, an issue. I think it's often cited as a reason to do services. I don't think it should be. If it is, that there's probably something very specific about that environment, but there are very high scale monoliths out there. I think it's definitely like possible. But anyway, what probably starts to happen is you have a lot of people all want to work on the same thing. Then they start stepping on each other, not while writing the code, but while rolling it out. So you got to roll it out. You cannot just flip a switch. And in this day and age, you never turn your software off. So like traditional software engineering techs, they're all like maintenance windows or whatever. You know what I mean? It's like not of this era, right? So our software, you can never turn off. And in a world where you can never turn it off, and you've got like maybe global reach and global audience, you're going to be making changes slowly. So like developer writes code it rolls out slowly for a day or so, maybe some hours, but not seconds. You know what I mean? It ain't no seconds, right? Well, the problem now is if you have one developer or 5 developers, it's probably okay. It takes like 4 hours to do a deploy. But if you have 100 developers, now, boy, they're probably gonna like start stepping on each other where like, oh, there's already a deployed away. So then you go, okay, we'll do a release train. Everybody get on the train, all the changes are gonna go out, they'll all go out together. But now what happens if one of them was bad? If you ship a bug, you gotta roll everybody's change back. And I think this is the reason to do services, is that you have a large engineering team and people are stepping on each other because you're changing it a lot. I think you can imagine other examples of things like why it'd be worth talking over the network, like maybe specialized hardware, like you're doing GPU inference, ML inference, or you've got some other large in-memory data structure, like a map, you're computing ETAs, right? And so you've got a bunch of road vectors in an in-memory, graph. Maybe you'll need a handful of those, right? And then it would be silly to embed that in the monolith, like that big in-memory data structure. Yeah, could be. But like in terms of the microservices where everyone's like, I'm going to move independently, like I think that's what forces you into that. Would you agree with that?
Yeah, I think I would. And of course, like you have much more experience than me in this regard, but I think that's definitely the case, at least in my experience. So you mentioned like, why would you want to make RPC calls from microservices? That kind of reminds me that it's not exclusive from the perspective of like backend development. For example, there was a application, Google Cloud itself. The front end for that is just one really big single page application. And it started out as that. And so there's not RPCs being invoked like from those pages to each other. They kind of actually realized the exact same thing. This single page application, when there's dozens of services on Google Cloud, there's thousands of developers working on it. And they ran into the same problem. If you're going to be deploying it, one team is going to break the other team, and you can't really do anything about that. You're going to have to wait days, weeks. And so they did something very interesting, and I'm not sure exactly how they did it, but they actually made that single page application deployable in independent units. And it was all a matter of like developer productivity. It had nothing to do with the scale. I mean, it's a single page application. It's going to be served the same way regardless, and it's going to hit the same backend endpoints. Yeah, I think that's exactly right. That in my limited experience, I think I would agree with that as well.
Yeah. Okay, cool. So I think that is actually like, that's like what we just pointed out is an interesting way of saying, well, that's not necessarily doing services, but they found a way to modularize it, to break it up so that people aren't stepping on each other. And, this kind of, there are different approaches depending on what it is, the thing that you're deploying. But somehow the issue of if you got too many people contributing to the same thing and you have to deploy it slowly, that's what makes you want to split it out into services. Okay, cool. I can tell you that Doordash did not have the luxury of this kind of careful analysis about thinking about like, oh, how should we do our thing? So this was before I joined, but they had the pandemic, and all of a sudden everyone was like, well, I can't go out. We have to order food. And so all of a sudden DoorDash had way more traffic than they had before, and that people needed bug fixed, and new restaurants wanted to onboard, and just like all this stuff, right? So the development velocity needed to increase dramatically, and so they hired a bunch of people, and I eventually was one of them. And but we were just stepping on each other like crazy, like it was not good. And the microservices like kind of effort at DoorDash started with some people just being very practical, going like, well, I've never done microservices before, but I am who works here. Yeah. So like I'll just do the best I can do, right? And they started, figuring it out, and, kind of kept learning like better ways to do it. We learned a ton, and I would say like some surprising things that I think that I learned about this is, like, I think I've been fond of saying this to my colleagues who all kind of groan when I say it now, but I think microservices are technical debt. And I say that intentionally because in that I do think that they help you move faster at first. I think if you've got a bunch of code running in one place and somebody says, you know what, why don't you I'm going to write some code over here. You just call me with the thing for a time. That does help that one person, that one team move faster. Like they didn't have to get involved in this whole team's release process and their development, whatever. They're just like, I wrote my code and I got it working. Now just call me over RPC. Like it actually did make it faster for that team, for that one thing. But the problem is, now that this thing is running, it's part of the call graph. It has to be up, right? So I know a lot of microservices theory talks about like loose coupling and, oh, what about fallbacks? And does everything have to be up? And if everything has to be up, then you've made a distributed monolith. And that may be true. And it's kind of like not a useful thing to say, I think, because like I think everyone to a certain extent makes a distributed monolith unless you really aggressively do fault injection, like really aggressively. I think you have a distributed, most people have a distributed monolith, whether they realize it or not, because they probably don't actually know what will happen if their things slowly grind down to a much lower performance and everything stacks up behind them, or, just all kinds of different failure modes. But okay, it's nice, ideal. None of the companies that I've worked for have ever made anything other than a distributed monolith either. Like all the things have to be up. They just have to be up. Right. And so you could say, well, you shouldn't do microservices, and maybe, maybe you shouldn't, but they are technical debt. They helped people move faster for a time. If there's one thing that I think that I wish people would change their thinking around, it's that idea, because it's not like it's black or white. It's not like, oh, microservices are bad. Like you got something in exchange for your debt, right? Like you borrowed against someone else's productivity in the future. And to be clear, the productivity that you're borrowing against is someone else later needs to come to you and say, oh, we have a feature that needs a change to services A, B, and C. And first we got to roll out a change to B. We got to get that thing rolled out. Now we got to roll out a change to B. And now we got to roll out a change to A. Now we got to make sure that the whole thing works. And none of those changes got rolled back. And then later, if you're lucky, we can go back and say, hey, B, you can clean up that code and do a release just to clean up the code. C, you can do it. B, you can do it. But what we find is there's very little incentive to clean up that old code. And it just has a way of like making certain kinds of changes, not only both expensive, because you had to do like 6 deployments there to make one change. You had to do 6 deployments. It's crazy. But also it tends sociologically, like it. My colleague Chris Micklejohn has this phrase where he calls microservices a socio-technical problem, and I think that's a really good way of putting it. It's like it's not purely. If it was purely technical, you would just say like, well, do a good design, do a different design. But like there are people motivations. Someone wants to get this product shipped right away, and they don't care what happens next year. They just want to ship it right now.
Kind of what you're saying is that it's like a people problem. It's like maybe a management problem or just like an organizational problem. I would definitely agree with that. In my experience, we had like a microservice that belonged to a different team originally. And then so we kind of inherited it at one point. And then you kind of mentioned like as the number of microservices grow, it's kind of technical debt. Like there could be consolidation. Like in hindsight, you look at it and it's like, well, these didn't need to be separate. You could consolidate them. And we even got to a point once where we had one service using a data store. And then we thought, well, rather than creating our own instance of that same data store for the second microservice, we could just reuse that same one. And so if they're reusing the same data store, well, then that's kind of feeling like a monolith. But, in that case, we were choosing to do the monolith to go faster, actually. We're saving time by doing that. And then it kind of creates the complicated issue where it's like you don't really know what it is anymore. And you're just optimizing for time. Yeah, it's kind of like a really hairy problem. And I guess I don't know necessarily the solution to it. If everybody had infinite time, you'd kind of clean everything up, but you don't.
For sure. And you must realize surely at this point that the comment threads are going to explode with people saying that microservices should never share databases. Yeah. Like, can you believe that the like absolute just like sacrilege that you've committed there by having 2 services share the same database? Like, how do you live with yourself? I mean, it must be rough. Yeah, I mean, dude, we did the same thing. I mean, like the early Doordash microservice deployments were just like migrations are hard, and like you want to make us like literally copy the data out of this database in this other database, like So, but anyway, I think the people. I wouldn't say it's just a people problem. I would think if it was, I don't think we would have so many engineers having so many opinions and being, you know, kind of wrestling with this challenge. I think it's at the intersection of people, you know, people at work and, you know, people like getting paid to make software, right? And the software itself. And there is a technical component. It's like the software resists being changed by too many people too quickly, right? Like that's the technical problem. It's like if you could find a way to safely let 1,000 people change the same thing and just know that they weren't breaking each other, well, then you would probably let them do that, right? That's the technical problem. But what we have is like kind of somewhere in between. So you say like, well, if you can put your stuff on the other end of this RPC, then maybe we can start to reason about, okay, did your thing break or did my thing break, et cetera. Even though in practice, a call graph that like propagates errors back, everyone on the call graph ends up getting paged, right? It's super hard to say like, oh, the reason I'm sending back errors is because 2 services down started sending back errors. You just end up paging everybody. And
we had the exact same problem where we had like latency charts like within our UI, and if like the upstream service like increased latency, then we kind of get paged as well. And it was never our fault. Like it was always a false alarm. And then so you kind of get into the habit where it's like the boy who cried wolf, and it's like every time you check it, there's nothing actually wrong. So then you get in the habit. But maybe if there's an actual issue, you're not going to double check it, and that's not a really good position either.
Yeah, that's right. That's right. Yeah, I don't know how much time both of us have, but I sent you a couple of links here. One is to Chris Micklejohn's PhD thesis, which he did on microservices, and based on research that he did at Doordash, which is where he talks about the sort of social technical problem. I also dropped you a link to a talk that I gave in 2016 that talks about where I suggest what might come after microservices. But there are a couple screenshots when I worked at Uber. There are a couple screenshots in there of a tool that they built at Uber that is super cool, and I've never seen anything else like it, that does try to tell you in a RPC call graph whose fault is it. So like if you're sending back errors, you're burning your SLO, you're doing, you know, whatever, like it's your service is in trouble. It's a tool that will tell you whose fault it really is, usually. I think it's pretty cool.
Interesting, yeah.
Like I mean, I think it is possible to build tooling to make some of these microservices problems like less bad.
I think people would be upset if I didn't ask this question. When it came to that migration, was it worth it to kind of go into the microservices direction, or is it more complicated than that in that it helped you initially, but now maybe you're kind of paying that tax, or have you already paid that tax and now, you know, it's just smooth sailing from here? What's kind of the situation right now?
No, I mean, that's a really good question. DoorDash had to do it. You know, they couldn't move any faster with their monolith architecture. It's theoretically possible with enough time, they could have re-architected the monolith and found ways to let more people work on it at the same time. So you found ways of chopping it up and saying like, all right, this is the monolith for you people, and this is the monolith for you people. And, you know, maybe the consumer, you know, browsing is one separate monolith, and the driver, you know, assignment is different. It just, you could imagine dividing it up into some chunks, right? It could have done that. They actually did do some of that, but even so, it was actually still the same code, because there's all this like shared code, and then the test suite was taking forever to run, and it was, you know, it needed a major re-architecture, and they didn't have time. You know, they needed to add features, fix bugs, and do stuff. There was no time to re-architect the monolith. And like I said, you can move faster at first by breaking stuff out. Where are we now? Like, I don't know. We're kind of still in this, like, there's no more monolith. Like, monolith gone. And, you know, we have hundreds of services, 500. I think you need about like 100 to like place an order and get it delivered. I think so. I think that's about right. You know, what was it worth it? Like, well, of course it was worth it, because the company was gonna just the monolith was grinding to its death. You know, it was like overwhelmed that you couldn't fix. No one knew how to fix it in enough time. So like, it was worth it, because we, you know, DoorDash still exists, right? Like, here we are. Had I joined the company sooner, I might have tried to steer us into some like slightly different directions. But like, you know, it solved the problem. like it made it so the company, you know, could keep growing. But at the same time, like we learned just like a ton about like what are the hard parts about microservices. And yeah, you know, it's stuff that we talk about in the blog post, but it's all that socio-technical problems. You know, it's like, oh, you want, like, we realize this problem, like if everyone would just please upgrade their gRPC client, then we can fix this weird interaction that we have sometimes. But there's very little incentive for people to want to like go upgrade their gRPC clients or pick your other library. Right? So like now you've got 500 individual things that are running some version of some set of dependencies defined by somebody somewhere. And then like, you want to say like, well, we really want you to go in and change your code to this, you know, the API is different. We need you to get on this new dependency. Like, it'd be really great if you did, you know, like it's kind of hard to justify. If I were to give people advice, I would say use as few as possible.
Right.
Like, are we stepping on each other? Okay, fine. Find like split it out then. And then like that is, I think, very reasonable. And not just, oh, by my domain-driven design ideas, the consumer service shouldn't know about the something piece of data. Therefore, it should be a separate service. Because what you have, I'll tell you a fun stat. Shoot, I wish I should have looked this up before. Okay, I'm going to get this a little wrong, but it's order of magnitude correct. The average fan out when you make a request to the Doordash like front end, the average fan out is you make about 1,000 RPCs. And I think that might actually be too low. I think it's more than 1,000. But like the reason is because of this domain principle, people are like, oh, well, I'm not the consumer profile service, so I shouldn't know about consumer profiles. So then like you go through this call graph and every step of the way, someone's like, oh, I need the consumer profile. So then they go get the consumer profile. And you know, you can have caches and stuff and that's fine. But like if you make everything have to go out over the network, everything is really going to end up going over the network like to an absurd degree, you know, where even simple things that you might think like, oh, could that just be a library? And then someone will say, yeah, but where's the storage come from? And then you have all these philosophical arguments about what's the right way to do microservices. And next thing you know, you have 500 services and 1,000-way fan out on average.
Yeah, that's really interesting. And honestly, I have one question for you, and maybe this will be a little bit controversial, but I think what you're saying kind of reminds me of how many times like programmers have this kind of like philosophy. They're kind of reading off like a Bible and like everything has to be done this way. Like, you know, there are some interesting things that people say, like, you know, when it comes to, let's say, like unit testing or like object-oriented programming, which, you know, some people have like their opinions on, but obviously like the context matters. Like you could say that this is a principle and like it shall never be broken, but if like the context of the problem is like dictating that, okay, well, the solution is just more simple to do it this way, or maybe we just don't need all of these unit tests, or like the unit tests aren't actually helpful at all. You can pretend like they are. You can pretend like it's going to help you sleep better at night. And of course, I'm not against unit tests or anything like that. I have an application where I haven't written a single unit test, and it's a relatively small code base, and I own it. I know every line of code in it. And so for that reason, I know 90% of the time when something's going to break, if I make a change, I'll manually test a few things. And to be honest, I do think it saved me time. Now, some people might say, well, that's dumb. And maybe it is. I don't know. Maybe I'll have a major outage in the future. But at the end of the day, it saved me, I would say, at least 50% of the development time.
Yeah. Okay. So yeah, your overall question is, are there just these ideas that programmers have that they stick to? They're not exactly sure why, and perhaps they stick to them at their detriment. And the example you cited is tests. 100%. Yeah, a example of that is that, you know, the thing I talked about like, oh, you have to have that as a separate service because that's how you do microservices. Testing is a fascinating topic. I too am not against writing tests. They have saved me many times. But tests have a curious way of making some changes harder, because they kind of like solidify the way a thing works. And you might look at doing something and you know that it would be right to kind of refactor something, move it around. But you're like, oh man, I'm gonna have to rewrite all these tests. And this is another socio-technical problem, but it tends to have, like, if in projects that have a lot of tests, tends to encourage people to work around the fact that they just want to keep the test suite working and not necessarily get the best architecture. Also, test coverage, I'm deeply frustrated with this as like a metric of performance, because all that really matters is your assertions. Like you can have 100% coverage and just say assert 1 = 1.
Right.
At the end, you've covered all your code. Good job. But there's no way to measure assertion quality. And I actually kind of wish there was, because if there was a way, I think I would be on board with, you should probably have some amount of, tests that with quality assertions, but lacking any way of measuring the quality of your assertions, I think it's kind of silly to chase test coverage numbers. But we do it. This is my personal opinion. We of course say, oh no, it's very important that you have test coverage, and it tends to be that people also, when they're in there making their tests, they tend to have good assertions, but it's like, it's a little misleading, like right. It seems like. But anyway, yeah, people have that. And it's really hard to give people a framework for understanding when they should question these kind of dogmatic ideas. I actually don't know. All I know is I've been doing this for long enough that I just kind of have a sense of when I can get away with it. And, and then people kind of look at me and they're like, yeah, but isn't 80 better than 70% test coverage? And we'll have those arguments, but I don't know, man. Yeah, this is a huge problem, I think, is that like, how do you know when this, ideal is serving you or is actually hurting you? It's a problem.
Do you have any other like last minute like hot takes where you think the industry is just wrong about something, or just a general trend that you've seen that's just like counterintuitive or just not helpful at all? How do you feel about object-oriented programming, I guess, or any other kind of?
I don't know. I mean, I think I'm one of these people who thinks that Go is a good programming language because it has fewer features and makes you think about your programs differently. And it's somewhat controversial, but I actually think it is a wonderful language for a large team to collaborate around.
I think the YouTube audience is going to agree with you on that. YouTube definitely loves Go.
Yeah, but I mean, that definitely gets me a lot of sort of heated discussions in the sort of professional software engineering community, who are like, yes, but why not Java or Kotlin? And they're like, fine. You want some modern compiled language? You should do Rust, and all that's true. But you know what? Here's my final thing is, I actually think that it's a shame that the industry has not produced an alternative. That we say, a monolith, obviously you make it Django or whatever, kind of thing. You start your company with, like, that's cool. And then when you break it out, you do microservices, and then like you read some like ThoughtWorks books or whatever, and you get the cool way of doing it. And I think it's bad. I think we should build frameworks that offer a different set of trade-offs. Like this trade-off of it's either all in the same thing or it's in a million things. And you have to like design it explicitly around these assumptions that it's all in a one monolith, or it's always making network calls all over the place. I think it's terrible. Like this industry like should produce new abstractions, new frameworks. I don't know exactly what they are. I'm actually working on one at Doordash that's not done yet, and we'll see how well it works. But it was a huge battle to try to get it funded, because everyone's like, but the rest of the industry is doing microservices. And I'm like, I know, but they're bad. And like, I think we should do better. I think we should do better as an industry. And, so like Google has that thing called Service Weaver. I think that's an interesting step in this direction. It doesn't fully address the issues of like, even if you write one program, you still might need to do like interact with this whole RPC ecosystem. But it's cool. I think it's a really cool project. But in general, I want the industry to do better. We should not have to pick between monolith and microservices. There should be something in between.
I guess, okay, last question, because I know people are going to want to know this. So do you have any advice for other programmers that are listening to this? Maybe they're in college, maybe they're working full time, and they kind of want to follow in your footsteps and get really good at application development, backend development, and architecture design. What should they do? Are there blog posts? Are there books they should read? Should they come join you over at Doordash? What should they do?
Well, I mean, that's certainly one way of doing it. I mean, here's the thing. I don't actually know, like I got super lucky in my career in that just I happened to be in the right place at some right times and, met some people that gave me some opportunities. I don't know, man. I just read a lot of software and I just don't, I don't, I'm not not satisfied with when someone says, here's this library, like just use it. Like I always want to know what's in there. I have a deep fear of dependencies. Like I don't like to run other people's code unless it's really important. And whenever someone says, hey, we're going to use this library, I'm like, all right, let's have a look, and I want to I read the dependencies and see what they do. I don't know. It's very hard to replicate luck, but I just think like if you care about your craft, that you care about like understanding like how stuff works and just like what good looks like and not necessarily getting sucked into these kind of dogmatic ideals like we were talking about. You just like good is contextual based on what kind of project you're working on. And I think it also evolves as the industry evolves, technology evolves. Just, I don't know, figure out how stuff works. Just make software better.
I honestly completely agree. And I'm so grateful. Thank you so much for like joining us. And I'm so glad that you kind of said some of the things that I feel like if I were to say them, I might get in trouble. But, now I got the credentials there. And I think like most importantly, a lot of these are like open-ended things. Like there's no one right answer. And at the end of the day, you're just trying to create applications that work and that serve users. And the tech behind the scenes isn't, the number one thing.
Yeah. So socio-technical problems. That's how you should think about it, and you should think that you should definitely think that microservices are technical debt. I mean, I'm just not satisfied with that. Let's do better. Yeah. Let's find a way to do better.